Hello students, in today's video I am going to discuss the genesis of periodic classification with you. So without wasting any time, let's begin the video and explore genesis of periodic classification. Genesis of periodic classification. Classification of elements into groups and development of periodic law and periodic table are the consequences of systematizing the knowledge gained by a number of scientists through their observations and experiments. The German chemist John Dobereiner in early 1800 was the first to consider the idea of trends among properties of elements. By 1829, he noted a similarity among the physical and chemical properties of several groups of three elements called triads. In each case, he noted that the middle element of each of the triads had an atomic weight about half of between the atomic weights of the other two elements. See table. Also, the properties of the middle element were in between those of the other two members. In the table of Dobereiner's triad, we can see that the atomic mass of sodium is half of the sum of the atomic masses of lithium and potassium. This is according to Dobereiner's triad law. We can also see some more similar triads in the table of the Dobereiner's triads. Since Dobereiner's relationship referred to as the law of triads seemed to work only for a few elements, it was dismissed as coincidence. The next reported attempt to classify elements was made by a French geologist, A.E.B. de Chancourtoi, in 1862. He arranged the then known elements in order of increasing atomic weights and made a cylindrical table of elements to display the periodic recurrence of properties. This also did not attract much attention. The English chemist John Alexander Newland in 1865 propounded the law of octaves. He arranged the elements in increasing order of their atomic weights and noted that every eighth element had properties similar to the first element. See table of Newland octaves, the relationship was just like every eighth note the resembles the first in octaves of music. Newlands' law of octaves seemed to be true only for elements up to calcium, though his idea was not widely accepted at that time. He, for his work, was later awarded Davy Medal in 1887 by the Royal Society, London. The Newland octaves table indicates arrangement of elements according to Octaves law. The periodic law, as we know it today, owes its development to the Russian chemist Dmitry Mendeleev's 1834 to 1907 and the German chemist Lothar Meyer 1830 to 1895. Working independently, both the chemists in 1869 proposed that on arranging elements in the increasing order of their atomic weights, similarities appear in physical and chemical properties at regular intervals. Lothar Meyer plotted the physical properties such as atomic volume, melting point, and boiling point against atomic weight and obtained a periodically repeated pattern. Unlike Newlands, Lothar Meyer observed a change in length of that repeating patterns. By 1868, Lothar Meyer had developed a table of the elements that closely resembles the modern periodic table. However, his work was not published until after the work of Dmitry Mendeleev, the scientist who is generally credited with the development of the modern periodic table. Mendeleev arranged elements in horizontal rows and vertical columns of a table in order of their increasing atomic weights in such a way that the elements with similar properties occupied the same vertical column or group. Mendeleev's system of classifying elements was more elaborate than that of Lothar Meyer's. He fully recognized the significance of periodicity and used broader range of physical and chemical properties to classify the elements. In particular, Mendeleev relied on the similarities in the empirical formulas and properties of the compounds formed by the elements. He realized that some of the elements did not fit in with his scheme of classification. If the order of atomic weight was strictly followed, he ignored the order of atomic weights, thinking that the atomic measurements may be incorrect, and placed the elements with similar properties together. For example, iodine with lower atomic weight than that of tellurium, group 6, was placed in group 7 along with the fluorine, chlorine, bromine because of similarities in properties. Figure indicates Mendeleev's periodic table, which is published earlier. At the same time, keeping his primary aim of arranging the elements of similar properties in the same group, he proposed that some of the elements were still undiscovered and therefore left several gaps in the table. For example, both gallium and germanium were unknown at the time Mendeleev published his periodic table. He left the gap under aluminium and a gap under silicon and called these elements A.E.B aluminium and A.E.B silicon. Mendeleev predicted not only the existence of gallium and germanium, but also described some of their general physical properties. These elements were discovered later. Some of the properties predicted by Mendeleev for these elements and those found experimentally are listed in table. Table indicates Mendeleev's predictions for the elements A.E.B aluminium, gallium, and A.E.B silicon, germanium. The boldness of Mendeleev's quantitative predictions and their eventual success made him and his periodic table famous. Mendeleev's periodic table, published in 1905, is shown in figure. Students, through today's video, you have learned genesis of periodic classification. I hope you enjoyed the video. So to keep receiving more videos from me, please like and subscribe to the channel and share it as widely as possible. That's all for now. See you in the next video.